here's my little model for our cantilever, and at the base of it, in the little cantilever holder piece that we took off in order to mount the cantilever, there's a small piezo which is going to be oscillating, and we want to oscillate it at just the right frequency so that it matches the resonant frequency of the cantilever. By doing that, I can have the oscillation amplitude here be quite small and still get a big oscillation amplitude out here, which is important. Let's say if I'm trying to image a surface which is covered with a layer of water, which basically all of them are, I need to have a big enough oscillation amplitude so that when the tip goes down and gets stuck in the water, it has enough energy to bounce back out. So, in order to get that good amplitude of oscillation, I've got to choose just the right frequency, and luckily, I guess it's not luck, the software is set up to do this very nicely. So I'm still in this engage window. I might as well, before I do the tuning, withdraw in preparation for putting my sample in. So I'm going to just lean on that until it's good and high so I can slide my sample in without having to worry about anything. And in fact, let me go ahead. Let's say if I was going to image this sample, I'll carefully slide it in. So first I put it flat off to the side, then slide it in. There's always a little bit of the laser beam, that spills off the side of the cantilever, and so that tells me where the cantilever is going to come down on the sample. So I can roughly position this to any part of the sample that I want, even when it's pretty far away. Then, again, here's something where you have to fight the instincts that you have from using many other software programs. You might think you want to click on OK. If you did that, that would transfer control to the computer, and the computer would start an automatic approach. That's not what we want. So instead I'm going to click on Cancel. Now I want to do that tuning I was just talking about, so I click on the little tuning fork icon up here, and then there's several windows that come up. I just click on the button that says Auto Tune, and if we look back over here, it's showing you the display of the process that it goes through while it's tuning. There are two different traces shown. The white trace is the oscillation amplitude on the vertical axis as a function of frequency. The yellow trace is the oscillation phase as a function of frequency. And those of you who have taken Physics 213 know that as we go through a resonance, if we're mapping amplitude versus frequency, we should see a maximum in the amplitude, and we should also see that the phase changes by 180 degrees as we go through a resonance. This cantilever has many different resonant modes, so in fact in this case we're going from positive 180 degrees down to 0 or something like that on the phase, but the most important thing is that it's changing by approximately 180 degrees. And in fact, for the most part, what we pay attention to is the white curve, the amplitude versus frequency. So you might think, well, I want to be operating at this peak frequency right here. The actual frequency, so right now it's quickly sweeping the frequency over and over again and mapping out this this trace for us about once every second. If I look very closely, I can see the details are changing about once every second. When we're in actual tapping mode, it's going to be oscillating this little piezo that's at the base of the cantilever at a unique frequency, which is graphically indicated by the center line of this graph, and it tells you right now it's 366.95 kilohertz, which is typical for this type of cantilever. So you might think, well, I want to position that so it's right at the peak of the resonant response, so that I get the maximum bang for my buck in terms of a lot of oscillation amplitude at the tip where I care about it, and a minimum oscillation amplitude down at the base so that I'm not shaking the whole AFM. But in fact, when I get close to the sample and start hitting it the way I am going to when I'm in tapping mode, that's kind of like a damping force. And the damping force tends to shift the resonance, this whole resonance spectrum down to lower frequencies. So we always pick a point that's slightly to the left of the peak, so that when we're in the actual operating range, hopefully the peak will shift to align with our operating frequency. It is important that if you're going to err on this, you want to err too far to the left of it and not on the side of getting too close to the peak, because there are strange image artifacts that happen if you're too close to the peak. But the computer is basically set up to pick that frequency for you automatically. So if the curve looks roughly like this, then the frequency is correctly selected. Very often, so the target amplitude is shown by this horizontal green bar. So right now you can see that when it's far away from the surface, it's going to be oscillating with this amplitude, because we're exciting it at this frequency. It's going to be oscillating with this amplitude, and basically the feedback system is going to try to reduce that amplitude down to this level by bringing the whole system down until it's hitting harder and harder, which reduces the amplitude. That's a lot of reduction of amplitude. So it's saying it's oscillating with a pretty big amplitude, and the feedback system is going to keep on approaching until the amplitude is reduced by almost a factor of 3. That's more reduction than I want. And so in order to tap the sample more lightly, I'm going to increase this amplitude set point, which is basically going to have the effect of essentially moving this green line up, or equivalently moving the whole white trace down, which is what it's going to look like. So right now this is set at 1 volt. I'm going to move it up to, let's try 1.3 volts. And when I hit enter, you'll see this whole thing jumps down by a little bit. And that's a more reasonable reduction in amplitude. It's a little bit less than a factor of 2. So that looks pretty good. We're going to adjust it more precisely later, but I like to have it roughly looking like this. So that, again, the center of the graph is slightly to the left of the peak. The horizontal line is occurring so that the intersection is at a point that's below the white line, but not too far, not too close to this baseline level. Once I've got that, I go back over to this screen and click on back to image mode, and now I'm ready to approach.